Alright, so 6.1a, we're going to be covering rational functions, and this first problem wants us to find vertical asymptotes. There's going to be a second part where we're going to find horizontal asymptote, and then third part we're going to find some ordered pairs. Alright, so for the vertical asymptote, it's always dealing with the denominator. You take whatever is in the denominator, you set it equal to 0, and you solve for x. Sometimes you might have to factor. In this case, we just have to subtract 2. And this is telling us that -2 is going to cause us a problem. So on the graph, there's going to be a vertical asymptote at -2. And so we're going to say x equals -2 is our vertical asymptote. Alright, now for horizontal asymptote, we are going to look at the ratio of the top to the bottom, the degree, that is. Okay, so there's a few rules. I'm just going to say DEG for degree of top is greater than degree of bottom so if you have this case, there is none. Okay, you will not have a horizontal asymptote. And this is for HA. I'm just abbreviating it HA for horizontal asymptote. So you got 3 scenarios. If the degree of the top is greater than the degree of the bottom, you have none. So we're going to keep this going. Degree of top is less than the degree of the bottom. Your horizontal asymptote is y equals 0. Top bigger, there's none. The bottom bigger, it's 0. Now if the degree of the top is equal to the degree on the bottom, your horizontal asymptote will be the ratio y equals a over b. So for example, if you had like, and I'm just putting a and b so you can follow the pattern. So let's say you got something a x to the third power plus ... whatever, and then on the bottom you also have something b x, and it's also to the third power. So if both of these have the 3 as their degree, and that's the biggest one, then the equation for horizontal asymptote is just going to be the ratio of those two numbers divided. Okay. And then there's one more called an oblique asymptote. Either you will have horizontal or oblique, not both. So you will have an oblique. So let's say OBL and abbreviate that. Oblique if degree of top is exactly 1 more than the degree of the bottom. Okay, so if the degree of the top is exactly 1 more than the degree of the bottom, so for example, like if you have something x squared ... and on the bottom you just have like x plus 1 or something. So this degree is 2, this degree would be a 1, and this is exactly 1 more. You would have an oblique. And I'll show you how to work that one when we get one. And because of the fact that the degree of the top is bigger than the bottom, like this, you won't have the horizontal, but you do pick up this oblique only if it's exactly one more. Now if it was like 2 or 3 more, then you wouldn't have either. But these are the rules. Okay, so in the problem that we have, the degree of the top is 0 because it doesn't even have a variable. The degree of the bottom is 1. So the top is less than the bottom. We're dealing with option number 2. So our horizontal asymptote is y equals 0. Okay, and now we want to find some ordered pairs that are on this graph, and you can graph it, or you can literally pick any points you want. I'm going to try to pick some that work out nice. Okay, so x and y. So I'm looking at the equation that we have, which is -9 divided by x plus 2. I know that if I divide 9 by 9, I get 1. So in order to get this to be a 9 on the bottom, I want this has to be a 7, because 7 plus 2 gives me 9. Okay, so I'm going to pick one of my x values to be 7, and that will make this a 9. And then -9 divided by +9 gives me a -1. Okay, so you just pick the points. I know that 9 is divisible by 3. So now if I make x 1, 1 plus 2 gives me 3. And if I divide -9 divided by 3, that gives me a -3. So I got 2 whole number ordered pairs. And then I can pick anything between. So let's just go 2 and -1. And I'm just doing 2 because 2 plus 2 is 4. And then I'll have a -9 divided by 4. That won't reduce. And then if I make x a -1, that will leave me with a 1 here. And -9 divided by 1 is going to be -9. So you can pick whatever you want, just so long as when you solve it, you get ordered pairs. Okay. So I'm going to put these ordered pairs in. 7, -1. We're going to do 1 and -3. We're going to do 2 and comma, and then division sign, -9 over 4. And then the last one, we're going to do -1 and -9. Okay. So any order pairs will work, but you can pick whatever that you would like to, and just solve it within this equation and then list them.